Today, we're going to talk about geometric mean theorem, which also is known as overlapping right triangles. So when the altitude is drawn to the hypotenuse, when the altitude to a hypotenuse is drawn, it will form three similar right triangles. So geometric mean theorem states that the altitude drawn to a hypotenuse is the geometric mean, which is also known as the mean proportional, between the two segments created on the hypotenuse. And we're going to solve these next couple questions and determine the value for x. So looking at my triangle here, I have three triangles. I have this triangle here on the bottom. I have this triangle here on the side. And of course, I have the big triangle that you can see here in yellow. So what we do when we look at this type of question is we're going to try to determine what sides we have and of what triangles. Now, I know that sounds kind of hard, but in order to do that, we're going to use a strategy. We're going to use basically a graphic organizer. So to do that, I'm going to create a crosshatch. I'm going to draw a triangle 1. I'm going to make this one triangle 1 and this one triangle 2. Triangle 2 and triangle 3. And we're going to do this to compare the sides of each. So we're going to compare the short leg of each. We're going to try to find the long leg of each. And then we're going to try to find the hypotenuse. So let's look and see what we have. Looking at triangle 1, which is in blue, do I know the shorter leg of the triangle? I do. It's labeled. It's labeled as X. This is the shorter side, and you can kind of see that that side is shorter, right? The long leg of that blue triangle is labeled with a 12. But the hypotenuse is not labeled. So in my chart, I'm going to leave it blank. In my pink triangle, I see that the shorter leg is labeled with a 12. The longer leg is labeled with an 18. But the hypotenuse, again, is not labeled. So I'm going to leave that blank. And in my big triangle, in yellow, I see that neither leg is labeled. The hypotenuse has two parts that are labeled, so I could figure out the length of the hypotenuse, but I already have as much information as I need to determine the answer to this first question. So let's look at it. Let's look at this table that I just drew. Right here in the table is actually your proportion. So your proportion is x over 12 equal to 12 over 18. And you're going to know that your proportion is set up correctly for all of these problems if this number here and here, if the two of the numbers across from each other are the same. So that's a little hint. All right, well, let's cross multiply. 18 times x is 18x. 12 times 12 is 144. I can divide 144 by 18 on both sides to get my answer. And I get x is equal to 8. Let's try another one. Here's number 2. Again, let's set up our chart. We're going to set up triangle 1, triangle 2, and the big triangle. Did I call it triangle 3? I did. That's okay. We can call it the big triangle. And again, we're going to talk about our short leg, our long leg, and the hypotenuse. So let's start with our small triangle. Triangle 1. Is the shorter leg labeled? It is. It's labeled with a 6. Is the longer leg labeled? Yes, it's labeled with an X. Is the hypotenuse labeled? No. Leave it blank. Next, we look at triangle 2, which I'm going to use as this triangle. By the way, guys, it doesn't really matter which one is which. Triangle 1 or 2 does not matter. But looking at triangle 2 in pink, is the shorter leg labeled? It is. It's labeled with an X. Is the longer leg labeled? No. But looking at that longer leg, I bet we could figure out what this number is that goes here. If the whole thing is 20 and this part is 6, can I subtract 6 from 20 to get the length of the longer leg? It's 14. And then looking at my big triangle, all I know is that the hypotenuse is 20. So again, guys, right here, I'll use a different color instead of yellow, is our proportion. 6 over x is equal to x over 14. And again, you know you're right because these x's are across from each other, the same number. In this case, it's just x. So x times x is x squared. 14 times 6 is 84. How am I going to determine the value of x? I need to take the square root of both sides. In this question, what I'm going to do, I'm going to write this as a decimal first, just so in case we need to round to the nearest tenth. The decimal, well, we're going to write square root of 84 first. And then we're also going to write that it's about 9.1651, which if I rounded, that would be about 9.2. But we need to talk about the square root of 84. To simplify that, we always look for the biggest perfect square. Now, I know that I was trying to get you guys to do it nicely before, but here's a hint. Your calculator will help you with it. So if you need to, actually, I'm going to write it over on the other side. Hold on. I'm going to write the directions over here under the triangles instead of to the right. So in your calculator, what you can do is you can go into y equals. You're going to type the number, divide it by x squared. When you do that and you look at your table, you're going to see some numbers that are decimals and some that aren't. In this case, you should see that 0 gives you an error, but it says 1 and 84. It says 2 and 21. 3 gives you a decimal, 9.3 repeating. But if you continue, you should continue down to see if there are any more whole numbers. Once you're less than 1, obviously, there's not going to be any more whole numbers. But you're going to pick, essentially, the two numbers here of the lowest whole number. And what that means is that your answer to this question in simplest radical form is 2 square root 21. Super nice way to help you out, isn't it? We're going to do the same thing for the next one. Let's see. This question here. Again, let's talk about short side, long side, hypotenuse of each triangle. So triangle 1, triangle 2, and my big triangle. And as we continue through these, I don't like to keep writing short, long, and hypotenuse, so I write SL for short leg, LL long leg, and hype for hypotenuse. So let's look at each of them as we go. Okay, small triangle. I guess I'll pick blue this time. I don't remember what color I was using before. In blue, my first triangle, the short leg on this is 5. The long leg is X. In my next triangle, my short side is X. My long side is 10. I don't even need to worry about the big triangle right now because I already have a ratio set up right here. 5 over X is equal to X over 10. X times X is X squared. X squared is equal to 50. Now again, if I want to, which I do need to get X by itself by square rooting it, I can say that X is equal, oh my gosh, let's try that again. X is equal to the square root of 50, or I can use my graphing calculator to get it, and I can use my graphing calculator to get it into simplest radical form. So in my calculator, I would type 50 divided by X squared in Y equals Y equals 50 divided by X squared. Then I see my table. When I look at my table, I see 1 and 50. And then if I look to the next whole number, I see 5 and 2. There are no other whole numbers in that table. So that means that 5 radical 2 is in simplest radical form. All right. We got 2 more to do. Triangle 1, triangle 2. So here we go. Triangle 1, triangle 2, and my big triangle. And we're going to be comparing my short leg, my long leg, and my hypotenuse. So starting with the smallest triangle, I see that the short leg is 9. The long leg is not labeled this time, but the hypotenuse is. The hypotenuse is labeled 27. Remember, the hypotenuse is across from the right angle. Looking at my second triangle, I'm going to color code it in yellow. I see that the only label that I have on any of those sides is that the long leg is X. And on this big triangle here, I have the short leg, 27, And I do have both sides of my hypotenuse labeled. It's not labeled all together yet, but I can add them. 9 plus x is 9 plus x, or x plus 9. Oh, it's lagging here, guys. This, guys, is my proportion. We haven't had one like this yet, but it's still right in my table for me. I'm comparing the short leg of one of the triangles to the short leg of the other, the hypotenuse of one triangle to the hypotenuse of the other. 9 over 27 is equal to 27 over 9 plus x. And again, those 27s are across from each other, which is exactly what you're looking for when you do geometric mean. So I'm going to multiply 9 by 9 plus x, and that's equal to 27 times 27. 9 times 9 is 81. 9 times x is 9x. 27 times 27 is 729. Now for this one, I'm going to subtract 81 from both sides. When I do that, I get 9x is equal to 648. And to solve for x, dividing by 9, x is equal to 72. Last one, guys. One more. Here we go with number 5. I'm going to draw my my chart underneath my table, or underneath my triangle this time. See if it saves me a little bit of space. All right, so triangle 1, triangle 2. Triangle 1, triangle 2, big triangle. And I'm going to compare the short leg, the long leg, and the hypotenuse. So let's start with triangle 1. In triangle 1, only one of the legs is labeled. It's labeled 5, and the hypotenuse is labeled x. In triangle 2, no sides are labeled, but I can figure out that this piece must be 10 minus 5, so the long side of that must be 5. But now let's look at the big triangle, because I do have more labeled for the big one. In my big triangle, I know that the shorter side is x and the hypotenuse is 10. Again, here is my proportion. 5 over x is equal to x over 10. Let's cross multiply. X times x is x squared. That's going to be equal to 5 times 10. 5 times 10 is 50. I can take the square root of both sides. I get x is equal to the square root of 50. Or in simplest radical form, you can type it in your calculator again. We already did this one. 5 radical 2. All right, guys, this is today's lesson on geometric mean. I will see you soon. Please let me know if you have any questions by commenting or emailing me if you're actually one of my students. All right, I will see you soon. Have a great day. See you in the next video.